Hello everyone, welcome back to this amazing YouTube channel of Infinity Learn by Sri Chaitanya. I'm your host and you all can call me AV. And guys, I welcome you all to the paper discussion of your LTC MPL chemistry of weekend test 15. So yes, let's not waste much time and quickly start the discussion. So the first question that you encountered in the paper was statement 1. Fluorination of ethane is explosive. That's a true statement. Iodination of ethane is reversible. That is also a true statement because there's a formation of hydrogen iodide, that is HI, which makes the reaction reversible. Okay, so both the statements are right. So question number 51, the right answer is option number 1. Okay. Proceeding further, 52. The hydrogen atoms of isopentane are labeled as 1, 2 and 3. Ease of replacement of this hydrogen atoms during photochemical bromination. That is nothing but free radical mechanism. Okay, that means a carbon free radical is going to form. And ease of replacement of hydrogen or ease of formation of carbon free radical goes in this way. It is 3 degree carbon free radical can form more easily, then 2 degree, then 1 degree. In the same way, 3 degree hydrogen can be replaced very easily as compared to 2 degree and as compared to 1 degree hydrogen. Okay, so if we'll see structure 3, okay, this carbon number 3, is it 1 degree hydrogen? It is bonded with 1 degree hydrogen. It is bonded with 3 degree hydrogen. And this is bonded with 2 degree hydrogen. So the order will be 2, 1, 3. The order will be what? 2, 1, 3. And hence the right option is option number 3. Okay, see 2, 1, 3 and hence that's the right option. 53. This is 1, 2, 3, 4, 5. Okay, so chloropentane in presence of alcoholic KOH. So alcoholic KOH will give you E2 mechanism, and in E2 mechanism there is no rearrangement. The product X will be, so from here halogen will go, from here hydrogen will go, and there will be a bond over here. So it will become 1 pentene or pent1ene. So option number 1 is the right answer. Okay. So for question number 53, option number 1 is the right answer. 54. 2-chloropentane, alcoholic KOH, again E2. There are two products possible. Now, pent1ene and pent2ene. And we know that E2 follows Hoffman's. Okay, in presence of alcoholic KOH, E2 follows what? Not Hoffman, sorry, Sedzev, and Sedzev says that more stable alkene should be formed. So in this question number 54, I'll go with pent2ene, and that will be the right answer. See, pent2ene is the right answer. Okay, 55. This is 1-pentanol or pentane-1-ol in the presence of concentrated H2SO4 gives you X product. So this OH will go. There will be a formation of carbocation. Okay, now this carbocation will rearrange itself on this and then it will undergo elimination, and hence the major product will be what? Pent2ene. So this will be the right answer. Okay, so 55, option number 2. Clear. 56. Statement 1. Acidic dehydration of ethanol is an example of beta elimination. True. Dehydrohalogenation of ethyl chloride is an example of alpha elimination. False. It is also beta elimination. Okay, so 1 is true, 2nd is false. So statement 1 is correct, statement 2 is incorrect, and hence option 2 will be the best answer. 57. Most reactive alkyl halide towards dehydrohalogenation is dehydrohalogenation. That means it will follow E1 or E2. Okay, and for both the things, 3 degree alkyl halide is more reactive than 2 degree and then 1 degree alkyl halide. Okay, so the best option is 3 degree, and 3 degree is option number 2. So 57, option number 2 is the right answer. 58. The least reactive alcohol among the following towards acidic dehydration. In acidic dehydration, you should know that carbocation is formed, and more the stability of carbocation, more is the reactivity of that alcohol to undergo dehydration, because the dehydrated product should be stable. So let us form the carbocation wherever OH is there. So this OH will be removed, OH will be removed, OH will be removed, OH will be removed. So all OH is removed and a carbocation is formed over there. Okay. So if we'll say this carbocation is resostabilized both the sides, so this is not the right answer. This is 3 degree carbocation with 9 alpha hydrogen. not the right answer. This is 2 degree carbocation with 3 alpha hydrogen stability and resonance, not the right answer. If you'll see over here in option number 1, there is only 6 alpha hydrogen and that to 2 degree carbon atom, no resonance. Okay, and hence I'll go with 58 option number as 1. Okay, 59. Isobutylene can be obtained in all the following reaction except acidic dehydration of isobutyl alcohol. So what is isobutyl alcohol? This is isobutyl alcohol, right? So OH will go from here and there will be a bond that is created over here. So this is isobutylene. That means we can prepare isobutylene from acidic dehydration of isobutyl alcohol. Acidic dehydration of secondary alcohol. So let us take any secondary alcohol. Here I am taking butane to all. If you will do the elimination, OH will go from here and you can form a double bond over here or the double bond over here. Either one, this or this, either one can be formed, but none of them will give you a isobutylene structure, and hence the best option over here for 59, option number 2. Okay, this option will not give you isobutylene in the product. 60. All the following can be used as a reagent for dehydrohalogenation except for dehydrohalogenation what we require is a base or basic character, whereas aqueous KOH is nucleophilic character. Rest all are what? Rest all are what? A strong base. Right? So 2, 3, 4 is not the right answer, and hence option number 1 will be the right answer. Okay. 61. Regarding fullerene, incorrect statement. We have to fixate on incorrect statement. It contains 26-membered ring. True. Carbon-carbon bond length is 154 picometer. That is false. Why? Because if I'm not mistaken, if my data serves me right, the carbon-carbon, there are two types of bond length. One is around 138.3 and the another one is around 143.4 or 5. And it is 154. So definitely this has to be the right answer. So 61, option number 2 is the right answer. 62. Regarding carbon dioxide, correct statement is, it is a linear molecule. True. The first statement itself is a correct statement. It is a linear molecule. How it is linear molecule? You must have studied this thing in chemical bonding. This is the structure of carbon dioxide where the hybridization is sp. Okay. And it does not have any dipole moment. Okay. Equal and opposite dipole moment. Right. Clear? So they can cancel out each other. Right. So dipole moment is not 0. It is actually equal to 0. So this is false statement. It cannot act as an electrophile. It can act as an electrophile. It is highly soluble. No, it is not highly soluble. Okay. So 62, option number 1 is the right answer. 63. Covalency of silicon and oxygen respectively in quartz is. So quartz is something like this: silicon, oxygen, silicon, oxygen, silicon, oxygen, silicon, and oxygen. So this is one structure of what? Quartz. So if you'll see, silicon can bond with 4. That means its covalency is 4. Oxygen is bonded to only 2 silicon atoms, whereas silicon is bonded to 4 oxygen atoms, right? It will be, say, oxygen over here, then oxygen over here, then oxygen over here. So if you see this silicon, it is bonded to 4 oxygen atoms. So 4 and oxygen is bonded to 2 silicon atoms. So it is 4 and 2. 4 and 2, best option is option number 2. 64. All the following are ionic compound except CF4, which is a covalent compound. Rest all are ionic. Rest all are what? Ionic. If you remember in group, in group 14, lead and tin fluorides, tetrafluorides are the only ionic compounds, right? Rest both are ionic compounds. This is covalent compound. And hence I'll go with option number 1. 65. The number of significant figures in 0.00900 is equal to. So its rule is very simple. Okay. First, from the first non-digit, whatever 0 comes on the left hand side is not considered. So these are not considered. So only three remains, and hence their significant figure is 3. Okay. So 0 before the non-zero digits are irrelevant. Okay. 0 before the non-zero digits are what? Irrelevant, and hence there are only 3 zeros. There are only 3 numbers, and hence its significant figure is always what? 3. 66. 10 grams of element A combines with 10 grams of element B. So A plus B gives you X. So this is 10 grams. This is 10 grams. In another compound, in another experiment, 20 grams of element A. So A is 20 grams. Combines with 30 grams of element B. So B is 30 grams and will give you Y. This data illustrates. So if I divide all the things by 10, so can I say 1 gram combined with 1 gram of B? Okay, clear? Similarly, here if I divide by 20, can I make it 1 gram of A? Gives you what? 3 by 2 grams of Y, right? And if I take the ratio, okay, if I take the ratio of B is to B, it comes out to be what? 2 is to, it comes out to what? 2 is to 3. Right. So similarly, can I say that 1 gram of A combines with, 1 grams of A combines with B in the ratio 2 is to 3 in two different reactions, and that proves what? It is law of multiple proportions. Okay. So out of all these things, option number 4 is the right answer. Okay. 67. Which one of the following statement is incorrect? 1 mole of sulfuric acid contains 2 gram atoms. 2 gram atoms means 2 moles. Okay. So H2SO4, 1 mole of H2SO4 will contain 4 gram atoms of oxygen or 4 moles of oxygen. So that is only incorrect. So I'll go with 67, option number 1. Rest all are true. If you'll see, molar mass of sodium is 23 gram, true. Atomic mass of sodium is 23, unified mass, true. 2 moles of glucose contain 12 moles of oxygen atoms, that is also true. Because 1 mole consists of 6 oxygen and 2 moles consists of 12. Okay. 68. pH of an acidic solution in contact with hydrogen electrode is 1. Okay. So we have given pH is equal to 1. We need to calculate reduction potential of hydrogen electrode. If pH is equal to 1, we can easily say that concentration of hydrogen is equal to 10 raised to minus 1. Right. Now talking about reduction potential, we know that hydrogen plus ion will take 1 electron to give you half moles of hydrogen gas, right? And electrode potential, that is E of a cell, is nothing but E naught of a cell minus 0.0591 by N log of this concentration. Okay, this pressure is not given, so we'll take 1 atmospheric pressure, and 1 raised to anything is again what? 1. So it will be 1 by what? 1 by what? Concentration of H plus ion, right? So E naught of a cell, okay, since it is in hydrogen, so it is 0 minus 0.0591 upon 1, okay, into log of 1 by 10 raised to minus 1. This 10 raised to minus 1 will become 10 raised to plus 1. Okay, so 0 minus 0.0591 log of 10 raised to 1, that is equal to 10. Log of 10 is equal to 1. So this becomes what? Minus 0.0591 volts, or 59.1 into 10 raised to minus 3 volts, or 59.1 millivolts. Negative sign. This negative sign is still there. So minus 59.1 millivolts. That option is option number 3. Okay. So 68, option number 3 is the right answer. Now, talking about question number 69. Okay, if we'll see question number 69, EMF of a cell, that is zinc solid in zinc 2 plus, or this is particular EMF of a cell. Okay, yeah. So EMF of a cell, that is zinc solid in this, okay, can be increased by, okay, so this reaction can be written as zinc, okay, we know that at anode what goes is oxidation and what cathode what goes is reduction. So zinc in the presence of Fe2 plus gives you zinc 2 plus plus Fe solid. Okay, here it is concentration, this is concentration C1, this is concentration C2. Okay, so if I want to calculate EMF of a cell, right, that is equal to E naught minus 0.0591 upon N, that will be equal to 2 log of concentration of zinc plus 2 whole divided by log of concentration of Fe2 plus. Now I want this value to be maximum. If I want this value to be maximum, what we can do is the difference between this E naught of a cell minus this value should be maximum. And if you want the difference should be maximum, that means this value should be as low as possible. And to make this value low, we have to increase the concentration of Fe2 plus. If I increase the concentration of Fe2 plus, this ratio will become smaller and hence the entire value will become small. So can I say that by increasing concentration of ions, we can increase the EMF of the cell, right? So the best option will be what? Increasing Fe2 plus. Okay, clear? So this is the right answer. Clear? So next, during the discharge of lead storage battery, sulfuric acid is consumed. Okay, lead sulfate is consumed at cathode, lead sulfate is consumed at anode. Specific gravity of sulfuric acid is increased. See, during the discharge, what happens is lead combines with lead oxide in the presence of H2SO4 to give you lead sulfate. This is the discharge reaction of lead acid battery plus 2H2O. This is what I remember. Okay, now if you'll see it carefully, here H2SO4 is consumed and lead sulfate is formed. Okay, so during the discharge of lead storage battery, sulfuric acid is consumed, so that will be the right answer. So hence for question number 70, option number 1 is the right answer. Proceeding further, the organic substance used to cover the surface of metal objects to prevent them from corrosion. Memory base, it is bisphenol. So you have to remember this thing, it is what? Bisphenol. Clear? Next, rusting of iron is an example of corrosion. Oxidation state of iron in the rust formed is, so rust is what? Fe2O3.XH2O. This is rust, and if you'll see the oxidation number over here, it will be +3. And as for question number 72, +3 will be the right answer. Okay. Next, the 15th group element with least melting point. It's very simple. In 15th group, the least melting point is nitrogen because it's the only element in group 15 which is in gaseous state. Rest, if I am not mistaken, they are in a solid state. So 73, option number 1 will be the right answer. Okay. And then 74. Group 15th group elements have low electron gain enthalpy values. The element with positive electron gain enthalpy is again nitrogen. They all have low value, but with the positive value is what? Nitrogen, because of its half-field stability. Okay, clear? So again 74, option number 2 will be the right answer, that is nitrogen. Next, which one of the following hydride is least volatile? Least volatile means what? It has least volatile means what? It has high melting point, right? So as we know that as we go down the group, okay, its van der Waals force of attraction increases and hence melting and boiling point increases. So what we expect, okay, what we accept over here is expected. It is expected. Okay, expected is if we go down the group, its boiling point and melting point will be on the this is the expected order. Okay, but the actual order, if I'll talk about melting point, okay, due to hydrogen bonding in ammonia, okay, due to what? The hydrogen bonding in ammonia, its melting point becomes maximum. Its melting point becomes maximum, and rest everything remains the same, that is BiH3. What we are supposed to ask is what the least volatile. Okay, again if you'll see this boiling point, if I talk about, again that is been disturbed. Okay, if I talk about boiling point, because of what? Hydrogen bonding in ammonia. And what has been found is it comes between arsenic and antimony. So it is something like this. So you expect the answer to be NH3, but the actual answer is pH3. Okay, so least boiling point, highly volatile. Okay, which one of the following hydrate is least volatile? Okay, so hence talking about least volatile, this is least volatile, right? And least volatile means what? My bad, I have given answer as pH3, but they are talking about least volatile. That means high boiling point. Least volatile means what? They have high boiling point. I have given you answer for the low boiling point. So least volatile is what? High boiling point. That is BiH3. Do we have answer as BiH3? No. Do we have answer as SbH3? Yes, the answer is 75, option number 2. Okay. Least volatile means what? Highest boiling point. Okay. Next. C, X, Z, B and D are the elements belonging to 15th group of modern periodic table. The correct trend of electronegativity. So the trend of electronegativity, you should remember this thing. Highly electronegative is nitrogen, and then the electronegativity decreases to phosphorus, to arsenic, to, and that is equal to this one. So this is increasing order. So D is what? If I talk about D, so this is D, B, Z, X and X. So X might be antimony or bismuth. So we have bismuth, we don't have antimony. So right answer is what? Option number 3. That is the right answer. Oh sorry, we have bismuth. Oh sorry, answer is bismuth. I have mistakenly marked in this particular answer. So let me just erase this thing. Yeah, so bismuth is the right answer. I said bismuth or antimony, but I mistakenly marked arsenic. So question number 76, option 2 is the right answer. 77. Which one of the following hydride has minimum thermal stability? And that answer is antimony hydride. Okay, so 77, option number 2 will be the right answer. These are something memory based. You have to make sure you know this thing. Ionic halide of group 15th is, again a memory base, bismuth trifluoride is the only ionic halide in group 15. So again you have to remember this thing. Okay, next. Pure nitrogen can be obtained by the thermal decomposition of barium nitride, that is BaN3 twice. If you will heat this thing, what you will get is barium plus 3 moles of nitrogen gas. So 79, option number 1 will be the right answer. Now 80. Ammonia is prepared by Haber's process. Moist ammonia can be dried by. Moist ammonia. Ammonia is a base. We should know this. It is a base. And these two are acidic in nature. Acid base is definitely not used to drying up. So this is not the right answer. If I take anhydrous calcium chloride will form an adduct, okay, or additional product with ammonia. So this is also not the right answer. And hence the only option remains calcium oxide, which is used as a dehydrating agent. Next. Which one of the following is neutral, colorless and paramagnetic gas? So if I talk about, this is neutral, this is acidic, neutral, acidic. So this is not the right answer, this is not the right answer. Talking about colorless, they both are colorless, but NO is paramagnetic, whereas N2 is diamagnetic, and hence 81, option number 1 will be the right answer. Okay. 82. Zinc plus dilute nitric acid gives you ZnNO3 twice plus water plus N2O. This is the answer. The correct, this Z value will be what? N2O. What is the option? Option number 1. Okay. Next. 83. Nitric acid is very good oxidizing agent. All the following metals render passive, means become least reactive or unreactive with concentrated nitric acid except magnesium. Rest all will render passive. So 83 1 will be the right answer. Okay, then phosphine is inflammable due to the presence of following impurities. Pure phosphine is not inflammable, but if we add P4 and P2H4, okay, if you add this two, it will become inflammable, and hence the right option will be option number 3. The right answer will be what? Option number 3. You have to add both the stuff. Okay, so that will become flammable. 85. Partial hydrolysis of phosphorus pentachloride. So phosphorus pentachloride, that is PCl5. If you do partial hydrolysis, you will get PO Cl3 plus HCl. Okay, here if you do partial hydrolysis, so it will give you this. And if you do complete hydrolysis, you will get H3PO4. This is complete. If not phosphoryl chloride, that is POCl3. And hence 85, option number 2 will be the right one. Option number 2 should be the right one. And then 86. In the halogenation of methane in presence of sunlight, the chain propagation step is, we are talking about chain propagation. Two free radical combining to give you this chlorine gas. This is termination. This is initiation, because chlorine is getting converted to free radical. Chlorine with CH4, a highly unreactive substance is formed, not possible. And hence the only option that remains is 4. That is what? Chain propagation step. So option number 4 is the right answer. 86. During photochemical chlorination of ethane, the possible products are butane, yes, can be prepared. Ethyl chloride, yes. And since no condition is given, so mono, di, tri, tetra, penta, hexa, all is possible. So even this is possible and even this is possible. So all 4 are possible, and hence I'll go with 87, option number D. All are possible. Okay. 88. Okay, so it is 1-chloro-2-methyl, both the cases. But over here if you'll see, this is non-bulky base. It is not bulky, but this is bulky base. And if it is non-bulky base, it will give you Sadzef. And if it is bulky base, it will give you Hoffman. So if it is Sadzef, double bond will be present over here, because this is an elimination criteria. And if it is Hoffman, the double bond will be over here. Compounds A and B are same compounds? No. Pair of chain isomers? No. Pair of position isomers? Yes, they are pair of position isomers, because the double bond position has been changed. This chlorine will go, okay, this chlorine will go, and this is the product form. So hence they are a pair of positional isomers. So 88, option number 3 will be the right answer. 89. Which of the following alcohol gives rearranged product in acidic dehydration? Rearranged. So what we'll do is remove OH from every places and form a carbocation. Here it's not carbocation, here it will be carbocation, and a carbocation. So if you'll see, this cannot rearrange, okay, because if it rearrange from the towards right hand side, 1 degree carbocation, not possible. And if you'll arrange on the left hand side, 2 degree carbocation with same number of alpha hydrogen, not possible. Option 2, again it's 3 degree carbocation, cannot rearrange. Even if it rearrange, it remains the same, cannot rearrange. But only one place it can rearrange, it can undergo 1,2 ME shift, that is methyl shift. And hence option 3 will be the right answer. 90. The product X in the given reaction, alcoholic KOH. But if you'll see, it's a very bad leaving group. It's a what? Bad leaving group. And if it is a bad leaving group, then we can say that Hoffman's dominate. Okay, and Hoffman's dominate means what? It will form but1-ene. So the product X will be but1-ene like this. So the option will be option number 4 is the right answer. Okay. 91. Identify the incorrect statement from the following. First, C14 has a very short half-life. False. It has very high, around more than 7,000 half-life period. Silicon is the most abundant element in the earth crust. False. Galena is lead sulfide, I guess. This is not the right answer. Again, it is false. Copernicium belongs to carbon family. It belongs to zinc family. So again, false. So all are false. So 91, option number 1 will be the right answer. 92. In 14th group, the following trend is true for carbon, silicon, germanium, lead, and then tin. If my knowledge serves me right, it is for melting point. First of all, do we have melting point anywhere? Yeah, there is a melting point and ionization potential. Yes, there is 2 melting point, but boiling point order is normal. Carbon, silicon, germanium, tin, lead. So hence boiling point will not be the right answer. And the only place where melting point is present is this, and ionization potential. Yes, that is also the right answer. So 92, option number 3 is the right answer. Okay, clear guys? I hope no doubts, no difficulties till now. 93. Identify the correct statement about silicones. Correct statements. They are hydrophilic. False. They are hydrophobic. They have high thermal stability. True. They have high dielectric constant. True. High dielectric strength. True. They are susceptible to oxidation. No, they are not susceptible to oxidation. So false. What they have asked is correct statement. So 2 and 3. 2 and 3 is option number 4. So option number 4 is the right answer. Then 94. EMF of a cell of this is equal to this. So if I want to write this particular reaction, it is zinc combines, okay, zinc combines with Ag plus with 0.1 molar to give you zinc 2 plus of 0.01 molar plus silver, right? So first of all, we need to calculate this standard EMF of a cell. That will be right hand side minus the left hand side. So right hand side is 0.8 of silver minus 0.76. So it will be 0.8 plus 0.76. So it will be 1.56. Okay, and then E of a cell is equal to E naught of a cell minus 0.0591 whole divided by n log of concentration of the reactant, that's concentration of product, is to concentration of reactant, that is Ag plus. Zinc will give 2 electrons. Okay, to balance we have to take, okay, so to balance for 2 electron, if you want to balance it, this will take 2 electrons, so this will be multiplied by 2 and this will be what, multiplied by 2. Clear? Sure. Got it. So EMF of a cell is 1.56 minus 0.0591 2 electron log of this Ag plus will be raised to 2. Zinc will be how much? 0.01, right? And this will be 0.1 the whole square. So 1.56, if I'll take 0.06, so it will be approximately 0.03 log of 0.01. I'll take it as 10 raised to minus 2, and this is 0.1 the whole square, that is 10 raised to minus 1 the whole square, and that is 10 raised to minus 2, right? And this is what? This is what? Log 1, and log 1 is equal to 0. So this entire terms becomes 0, and hence EMF of cell is equal to standard EMF of a cell, that is 1.56 volts. So answer will be 1.56 volts. Option number 4 is the right answer. Okay. And then reduction potential of chlorine electrode in contact with 0.001 molar HCl solution is. So we are doing reduction. Okay. So reduction means what? Chlorine, that is half mole of chlorine, will take an electron to get converted to Cl minus ion. Okay, and what is the concentration of that Cl minus ion? That is 0.001 molar. Okay, so EMF of a cell will be equal to 1.36 minus 0.0591 whole divided by 1, because number of moles of electron is 1, log of concentration of Cl minus ion, because the pressure is not given, so we'll take 1 atmospheric pressure, so it will remain 1. Okay, and root of 1 is always 1. So 1.36 minus, I'll take it as 0.06 log of chloride minus iron. This is 0.001, so I'll take this thing as 10 raised to minus 3. So this is 10 raised to minus 3. So that is 1.6. This minus 3 comes into multiplication, becomes plus, to 0.06 into 3, because log 10 is 1. So 3 6 are 18. So this is 0.18 plus 1.36. So 1.36, 0.18. So 8 6 14, 5, 1.54 around. So 1.54 around. Option number 1 will be the right answer. Okay. And then 96. Regarding dry cell, the incorrect statement is, it is a primary cell. This is true. Zinc electrode is negative electrode. This is true. Oxidation of Mn changes from +3 to +2. I don't think so. What I remember is changes from +4 to +3. So this will be the incorrect statement. Tetraamine zinc 2 is formed during the discharge, and that is also true. So hence the only option remains is 96, option number 3. Okay. 97. Which one of the following on thermal decomposition does not give elementary gases? So what I know is this will form a gas of NO2O. So this does not give. Ammonium chromate will give you nitrogen elementary gas. Perchlorate will give you oxygen. KMNO4 will give you oxygen. So all these three will give you elementary gas except option number 1. So that will be the right answer. So let's go to question number 99. Which one of the following oxo acid of phosphorus acid is dibasic? And the right answer is option number 4, because if you draw this structure, it is P double bond O, O, P double bond O, OH, OH, H, H. So there are two hydrogen or two acidic hydrogen present, and hence it becomes what? It is what? Dibasic acid. So question number 99, option number 4 is the right answer. Okay. Then question number 100, phosphinic acid. You should know phosphinic acid is also known as hypophosphorus acid. Hypophosphorus acid, and hypophosphorus acid is H3PO2, right? And that is your option number 3. Clear? So I hope guys you must have understood all the questions and their solutions and how to approach in solving such questions. But still, if you have any doubts, any difficulties with any other question, please post it in the comment section. I'll definitely revert with the solution of it. So guys, thank you so very much for joining this solution video with me. Take care guys and keep smiling. We'll meet next time.